So what I wanted to do is just summarise the challenges which we are seeing for the past 3 years, but mainly focused on this year. So earlier in India this year, so we've done verification futures in India. These were the challenges that came from India from 3 different companies: NXP, MaxLinear, and ARM. Again, AMS comes up quite a lot, and one of the later slides I have the analysis of all the challenges and what the highest challenges. AMS is a big challenge. It's okay. And dynamic power, as Mark mentioned, as our technology drops, the need to manage power becomes much greater, and so dynamic power verification becomes more and more important to people now. MaxLinear, again, focus here is on requirements-driven verification. We heard that from Martin today as well. We're seeing that a lot more in the marketplace now as people try to move to requirements-driven verification. Some of it driven by standards such as ISO 26262. And I guess it depends what type of industry you're in. But I know quite a few industries where safety is an issue are starting to mandate certain verification flows for companies. ARM, as you can see there, is an issue with system-level coherency as they more and more, as we've seen this morning, the number of CPUs on our SoCs increases. The issue of coherency becomes more and more difficult to verify. I know we did a lot of work with ARM, and verifying coherency is a huge issue for companies like ARM. And they're trying to use formal as much as they can, because they do realise that simulation-based verification of coherency is probably not sufficient. There's just too many corner cases. And I know ARM putting a lot of work into coherency, and I know they're working quite closely with Jasper. And hence the issue of exploiting formal. I guess, again, we heard from Mark earlier this morning that not every companies now realise that to exploit formal, you don't necessarily need an army of PhDs, which is what potentially happened when Intel first started to exploit formal. I think companies are realising now that you don't need just huge numbers of PhD students to exploit formal. And I know the formal companies, EDA vendors, actually making it a lot easier through system-level applications. So you could, for example, through interconnect verification, X propagation, crop domain crossing, that type of thing. So these are the ones from across Europe. The first one there from Chris Brown is quite interesting because, again, Mark mentioned this morning. And he's looking through standardization for improved EDA competition and potentially innovation. So I think Chris sees that the move to UCIS and standardization through UCIS will open up both innovation and competition, which is probably good for our industry. So he's taken quite a wide view of our industry on that. Simon Burek of Ericsson is looking at test bench quality. I know, obviously, Synopsys would push certitude towards that for doing test bench qualification. Again, he talks about power, but also there on fewer bugs, earlier bugs. This is something we spent a lot of time with ARM on as well, of how the biggest way to improve verification productivity and improve debug is not to have the bugs there in the first place, of course. That's, I guess, the holy grail of our design and verification industry. But how you actually go about ensuring there are fewer bugs initially in the design is a challenge. And I know a few companies are trying to push some of the verification back to some of the designers through tools like formal verification, where maybe the designer captures a property of the design and then proves that in the formal tool before they pass it over to the verification tool. We just heard from Andy and we just heard from Tim, so I'll skip on to those, for the French and German ones. So we heard from Martin this morning But a couple from France, Jerome Bombal, was with TI. TI obviously shut down in Sofia earlier this year. He's moved across to Samsung. And an interesting one from him there is the software libraries. Because I think at SOC level now, we do have, most people are using C-based verification at SOC level and therefore building up big software libraries. You know, verification engineers now spend most of their time writing, a lot of their time writing software. And I guess you could even argue that SpecMan and System Verilog at one level is just writing software now. So how he manages those big libraries of verification software, which for him is a big investment. It's a huge investment in time and money to build up those libraries, and how you best manage them, and how you make sure you get maximum reuse from them. And Patrice and Yassin from ST have a challenge in interconnect verification. Again, Mark explained that well this morning how the interconnects now becoming a lot more complex for our SOCs. Okay, so these if we analyse the challenges we've had from verification features for the past 3 years, from 2011 to 2013, I think all in all is about 55 challenges we've had from about 20 different companies. And these are the top 9. So these are the ones that made it where it's been quoted. So this is the number of times it's been quoted. So at 55, complexity and integrating languages, people find their top challenge, and as you can see coming down there. I was quite surprised to see requirements-driven verification so high. It may be just because the speakers we chose, but it's actually come from quite a few different companies, requirements-driven verification. So obviously quite a few companies have started to see issues with that. And if you want to see all of them, they're all there. And again, as I say, that's different people from different companies choosing what their top 3 challenges are, and that's the analysis. So I'll leave that up for you to look at if you want time. So, and I think now we're going into break. Is that right, sir?